MQ-28A Ghost Bat just flew as an autonomous wingman for the F-15EX over the Pacific in the Valiant Shield 2026. With F-15EX, Boeing is taking an early lead with the MQ-28A.
The successful integration of the MQ-28A Ghost Bat with the F-15EX Eagle II during the Valiant Shield 2026 exercises marks a monumental leap forward for autonomous combat aviation. Conducting these high-intensity tests directly in the Pacific theater provided an invaluable, realistic environment to evaluate manned-unmanned teaming capabilities. Engineers and military planners deliberately chose this maritime geography to stress test the drone advanced data links under harsh atmospheric conditions and over immense operational distances. The deployment successfully validated how autonomous flight algorithms and mission software synchronize in real time with a crewed fighter jet during complex maneuvers. This successful operation yields critical, high-fidelity telemetry that is absolutely essential for shaping the doctrine of future air dominance. Testing this advanced hardware directly in the Pacific is a strategic necessity driven by the preparation for potential future conflicts in the region. The vast distances and isolated islands of the Indo-Pacific demand a complete rethink of traditional aerial logistics and combat endurance. Operating the MQ-28A around remote locations like the island of Rota allowed the military to refine expeditionary logistics for advanced composite unmanned airframes at austere forward bases. The data gathered from these flights directly solves critical scientific challenges regarding communication latency and autonomous threat response in a highly contested maritime environment. By proving the technology works in this specific theater, the exercise established a baseline for how autonomous wingmen will project power and defend cross-domain networks in future Pacific scenarios. From a software engineering perspective, the mature MQ-28A airframe served as the perfect physical surrogate to test the United States Air Force overarching collaborative combat aircraft architecture. Because official domestic prototypes are still in earlier phases of development, utilizing this flight-ready platform allowed the Experimental Operations Unit to immediately validate artificial intelligence flight behaviors. The technical focus centered on the seamless handoff of tactical command between the pilot in the F-15EX and the autonomous systems on board the drone. The performance metrics and sensor fusion data harvested during these missions will be directly implemented into the software of America's next-generation autonomous fleet. This makes the entire Pacific exercise a massive research and development success that accelerates the timeline for operational artificial intelligence. While these flights demonstrated impressive technical readiness, the status of the MQ-28A within the United States defense framework remains experimental. The airframe utilized in the exercise is a prototype belonging to Boeing Defence Australia, integrated specifically to serve as an operational asset simulation for data collection. The formal procurement contracts for the Pentagon Collaborative Combat Aircraft Increment 1 program are currently held by Anduril and General Atomics. To maintain the program momentum, Boeing is actively presenting these proven Pacific capabilities to international partners, including Australia, Japan, and Germany. This global outreach highlights how mature technological demonstrations can be used to establish international interoperability while preparing for future competitive bidding opportunities like Increment 2.